Good afternoon, everybody. My name's Steve Holmes. I'm an application engineer with Leader Electronics. I've been in the video business for well over 35 years and having a blast at what I do. So let's see where we go. So today's presentation is all about NMOS and what this crazy little thing is and why do we have it, what does it do for us, and how it all works. So from my end of the business, once upon a time, if you would have asked me something about NMOS, I would have told you that it's a metal oxide semiconductor. And that's kind of taken on a new meaning now in this new world because it is the control system for 2110. So when they built 2110, like normal SMPTE standards, it defines everything about the transport. Doesn't define the control of that transport. And if you think about it, it never, in the SDI days, it never did anything about the control of SDI. That was always up to the people who built routers and everything else. So we really haven't departed from where we're at. So rather than manually having to enter 40 gazillion IP destination addresses in a host table and have all this stuff memorized, we still want to be able to use the same equipment. We still want to be able to walk up to a router panel, push source, destination, take, and things work. We want to be able to route things to a switcher panel. So this is where NMOS comes into this whole picture. So this is where the Advanced Media Workflow Association, AMWA, came in and got together with a group of people and came together and developed this. So the Network Media Open Specification, NMOS. So this is where it all came from. And the whole thing you're looking at here is a complete control system, but the piece that we're actually going to look at is this little red box over on the side. The other two pieces are what each vendor provides individually. And what is in that red box is actually the NMOS piece. So the control system that the vendors have has to be able to talk to that piece. And so an important thing to remember is that SDI 2110 is a standard. NMOS is a specification. There's not a huge difference between the two, but it's when it gets down to looking at how some of the vetting is done and the publishing of the difference between those two. They're both set out and say, hey, this is what we need to do, and this is how we need to do it. So inside of NMOS, we have that piece over on the left-hand side, and that's what we're going to concentrate with, and not the vendor control system, because every vendor is going to have their own control system that's going to talk to NMOS. So inside of that registry, in that system there, NMOS, we've got three different components. We actually have the registry down in the bottom left corner that goes out, finds all of the pieces within the 2110 architecture, looks at what they can do, and puts that into a registry database. Then that registry database makes that data available in a query server that the independent gear can go query, go pull that data and get all the connection information that it needs and where it's going. NMOS is a whole series of IS standards or specifications that deal with everything from hooking up transmitters to receivers, tally, audio. But in this little presentation, within the time we have, I'm just going to mainly talk about ISO 4 and ISO 5 because those are the connection pieces that make video work from a standpoint of you need to get this server to this receiver and those things. So the presenter right after me is going to take this and go a little farther into some of the newer things within NMOS. So if you want to know some of the newer things, stick around because they're going to cover some of that in the next section. So in NMOS, a device is represented by a logical block of functionality. A node inside of that device is a host for one or more devices. Typically, those devices are going to be logical things like senders and receivers. And that's where ISO 4 and ISO 5 sit for that. So we're going to turn around and look at ISO 4, the registration. So when a device is put onto the network, it needs to find NMOS, NMOS needs to find it, and it's going to be done using some protocols that have been around for a long time to turn around and discover each other. And then an SDP file, which is a session description protocol file, will be sent from that receiver to the database. That SDP explains everything about that device, whether it's a sender or whether it's a receiver, and all of its parameters and what it can do. So those three things that happen down here. So there's a registration IP API that allows a node to register. And then once it's registered, that query server is what's going to make it available for all of the exterior equipment. There is an API that can be used without an NMOS server where you can do a peer-to-peer connection, but that's not the normal way that we use this. We generally use it with that query service. So the RDS, the registration system, executes either an MDNS or DNS announce. It says, this is who I am, and this is who you need to connect to. And then the senders or the receivers will send their SDP file to that, answering that MDNS. So the node will post who it is, and it'll loop for all of its senders and send the SDP file for all of its senders. It'll loop and send something for all of its receivers that it has, and that then will appear in the registry database and then be made available in that query service. There are some tools out there, some free tools, and especially if you're making a brand new network, I highly recommend the Riedl's NMOS Explorer, because when you're in a sandbox and you're building a brand new network, it allows you to actually go on there, look at all of the nodes, look at the senders, look at the receivers, and you can actually even drag and drop connections like you would on a router panel and make sure everything is working and everything is showing up. It's a sweet little piece of free software that really helps. So you've got the nodes that show up, you've got the devices that show up, and then the senders or the receivers that happen to be in those devices will all show up. So it's a really nice thing to be able to use. So the order in which this takes place is the nodes will find the registration server. The registration service then will put it into the registry, write it to the registry, and then that data will be made available in the query service. So now this is where ISO 5 is going to take over, because ISO 5 is the piece of the standard that now manages the connections. How do I connect this receiver to this sender? So the ISO 5 piece is the one that is going to do the control of typically receivers, is where we typically think of this being used. So if I need to connect a receiver to a given sender, I'm going to use ISO 5 to drop that SDP file on that receiver. That receiver then in a conventional COTS network is going to then forward an IGMP join to the network. and the network will provide that flow to that receiver. If it's not a conventional network and the sources are being force-fed, you still have to send the ISO5, the SDP file to the receiver, because it still needs to know what multicast to set up for. It may not have to issue the IGMP join, but it still needs to know which IP addresses that it needs to turn around and look at. So in order to interface with the user service, so to do something like as simple as a router panel here, you can turn around and the NMOS admin server, which is the user supplied data equipment, is going to query that query server and load into its database everybody, all the senders and all the receivers that are out there. So when you turn around and hit source destination take on the user interface, it's going to talk to its admin server. The admin server is then going to issue that SDP file, that session description protocol file, to the receiver. The receiver will then do the IGMP join, and voila, you get the video. Now, this happens in microseconds, folks. It is done all the way through the whole chain. It is incredibly quick. So this is what, and it's going to be really hard to see and make any sense out of it, but this is what an SDP file would look like. It has a header in it. It has the primary network and the blue network, which a lot of people call secondary network, but neither one are primary or secondary. It's just the red and blue network, and all the data for those individual networks inside of it. And we'll tell you the resolution and everything else about the IP address. And the biggest piece is the destination address that you want to turn around and talk to in there. It'll also specify the video format down to, is it 10 bits? Is it 12 bits? Is it SDR, HDR? What's the frame rate? And everything else is contained in that SDP file. So the -20, there's a -30 SDP for the audio, and then there's a -40 SDP that would be for all of the ancillary data. Since in 2110 we're sending each one of these separate, we have to connect to each one independently. But the system can set up and send all three of these SDPs at one time, and each individual piece will turn around and do the setup for this stuff. So the neat thing about NMOS is it's all web-based. And if you need to troubleshoot it, all you need is a laptop and a web server or a web page. And you can go out and query the registration system, and you can query your independent nodes and make sure you have connection. So what you want to do is get into your network and put in the address of those particular pieces. So a little bit of troubleshooting goes a long ways. And since it is all HTTP based, it makes it very simple to troubleshoot and find out that, hey, this piece of the network, I can talk to all my nodes in all my equipment, but I can't get to the registry server. Or if you're up higher in the food chain, you can say, hey, I can talk to my registry server, but I can't get to my nodes. And then you can work out what's missing and why is the MDNS not getting through there to make that connection, because if you can't get through, it can't get through. So you can hook up a laptop. If I want to talk to the nodes down there, I can put in the IP address for the nodes, their port, and I will get a response back. If I want to talk to the registration server, I can turn around, put in the registration server, its IP address, and /X NMOS, and it will respond back to me. And if you can get those two things, the system will talk and do what it needs to do. The hardest piece that I have seen yet is when people divide their networks onto two different network legs, and you got a router sitting in the middle, and you need to be able to get across that route. That is the hardest piece. So sometimes in the receivers, you may have to help them out and put that route actually in the MDNS to say, go this way to turn around and send it. So you can turn around, and these would be the responses you get back. It's only about 4 lines of JSON. So it comes back as a JSON tag in there and lets you know that, hey, I've got connection to the RDS. I've got connection to the nodes. So it makes it really simple to turn around and troubleshoot that piece and be able to look at it. This is one that has an error in there that is going to be really hard to see. But in a SDP file, it will have the RTP packet type. Unfortunately, that RTP packet type's in there 6 times. Which one is the receiver or the RDS going to look at? Not the RDS, but the receiver. When you send this SDP file to that receiver, which one of those is it going to look at? Yeah, exactly. Don't know. In this case, it's really hard to see, but the very bottom one was different than the rest of the 3. Most of the systems I've seen take the last one that's entered. And it was the wrong packet type for the video that was coming in. And they didn't realize it because in the control system, you cannot see this as a complete SDP file in any control system I have seen yet. The only place you see this as a completed SDP file is when it's delivered to the receiver, because it's coming from several parts of that control system, because it's got its audio piece, it's got its video piece, it's got its IP address, it's got its destination addresses, and it being put all together and then being delivered as a single SDP file. They had no idea that one of the tags was wrong. And they actually had to go back to the code because they only had one place to set it. And it wasn't setting that last one in the SDP when it was being delivered. And the device I was working with read the last one. And it kept coming up wrong. And they were trying to blame, in this case, it was actually our equipment that was wrong. And I said, no, here's your SDP file. So you always want to look at the SDP file from the receiver, because that's the only place it's going to be a true SDP file and will be the data that the control system is actually putting together and sending out, coming into this stuff. Different devices will display how many receivers you have. There's a video receiver. In this case, there was actually 4 audio receivers running. I'm looking at the video receiver, and it's actually giving me the SDP file down on the bottom. At least in all the Leader and Fabrics gear, you can put in a USB stick, hit copy, and say, listen, Mr. Vendor, here it is. You screwed it up. And have them fix it. In some of the gear, gives you a nice green light, red light screen. You drop an SDP on there. You get all green lights. It's all good. If one of these turns red, you can click on this screen and it'll turn around and give you the entire SDP file. So we got about a minute for questions, if anybody has any questions. Also, contact me. I wrote for Leader a complete app note, about a 40-page app note on NMOS that is available, folks, for you in here. I hope you enjoyed this quick presentation on NMOS. It's very quick, but I think I hit most of the highlights going there. Come to the Leader booth, see me, talk to me. I've got my business cards. So if you have any questions at all, please come see me over on the side. We appreciate it. Thank you, guys.